In this video, I will take you through the procedures, advantages, and disadvantages of stratified sampling. In this example, we want to take a random selection of 10 students in a class. This class has 12 female students and 8 male students. One reason to go for a stratified sampling approach is if we believe that certain groups have different responses. In this example, we may believe that male and female respondents have different responses. It can also be that we want to improve the estimation for each group separately. For example, if we want to do a subgroup analysis for female and male students. In this case, we need to ensure that we have sufficient number of students sampled for each group. The first step of stratified sampling is to partition the population into groups called strata. Strata are groups which are mutually exclusive, which means that every participant can only be in one stratum. The population is homogeneous within a stratum. That means that people in the same stratum have, in this example, the same gender. And the population are heterogeneous between strata. In this example, that means that people in a different stratum have a different gender. Once we have decided what our strata are, we need to decide how the sample size will be divided across the strata. We could divide the number of respondents equally across the strata. This is what we call equal allocation. We simply divide the sample size by the number of strata to find the stratum size. In this example, we would have to divide our sample size of 10 over 2 strata, which would give us 5 respondents in each stratum. Of course, equal allocation is not always 100% equal. In this example, if we were to have 3 strata, we would have one slightly larger stratum. Another strategy is to divide the sample size proportional to the stratum size. This means that the relative share of the strata in your sample is the same as in the population. In this example, our population consists for 60% of women and for 40% of men. If we want our sample to reflect that distribution, then 60% of our sample should be female and 40% should be male. From a total of 10 respondents, that would give us 6 female respondents and 4 male respondents. Depending on our method of allocation, we end up with a different sample. With equal allocation, we end up oversampling male respondents, as they account for only 40% of the population, but account for 50% of our sample. Likewise, female respondents only account for 50% of our sample, but for 60% of the population. This means that we have undersampled female respondents. If we want a reliable estimate from our sample, we will have to perform a weighted analysis to account for the disproportionate selection. Our proportional sample is self-weighted, which means that we don't have to adjust our analysis for disproportionate selection with weights. The disadvantage is that if we perform a subgroup analysis for female and male students separately, we will have a more precise estimate for female students because our female sample is larger than our male sample. After deciding on the allocation method, we can start the selection of respondents within each stratum. We have chosen to distribute our sample size proportionally to stratum size. This means that we have to randomly sample 6 female students and 4 male students. You can select the respondents within each stratum based on your preferred methods, such as simple random sampling or systematic sampling. The advantage of stratified sampling is that you can study variations in different strata. You can also increase the precision of your estimate because the variance is likely to be smaller as when you would do simple random sampling with the same sample size. You can also organize your fieldwork by stratum. For example, if your strata are geographic areas, in which case you could allocate one team to each area. The disadvantage is that you will need a separate sampling frame for each stratum. And when a disproportionate sampling strategy is chosen, you have to account for that with weights, which brings another layer of complexity to the analysis.